When I was asked by Teachers TV to teach a maths masterclass, I decided to tackle a topic that can be brought alive by a hands-on approach to suit a range of pupil learning styles. It's a topic that is possible to have a lot of fun with. I'm hoping that's what this group of Year 6 students from a number of North London schools will think too. Interesting. Well, hello everybody. Hello. Right, if you've got a fraction on your card, will you raise it in the air? A fraction. Hold it up. Excellent. What about decimal? Hold it up. Decimals. Hooray, decimals. I love decimals. And a percentage. And anything else? Oh, you two look a bit puzzled. 2 question marks. We'll come back to those in a minute. If you've got a fraction, what I want you to do is, in a moment, find the equivalent decimal and the equivalent percentage. Because there's 3 ways of saying the same number. If you've got a percentage, 25%, you want the matching fraction and the matching decimal. All understand? Yes. So, I want you all up, I want you to get into your groups, and I want you to find your family groups. There's 3 in your family. When you found your family, give each other a hug. When you found your family, first family. Only hug if there's 3 of you. Line up. Family, line up here, please. Family over here, girls. Where's your family? Come over here. Don't cry. Just stand over here. Oh, bless him. Bless him. Right, and oh, look at you. Oh, do you love each other? Do you love maths?
Yeah.
Brilliant. Okay, just move yourselves up here. Shuffle along this one. Yep, you can go just behind the goal. Good view. Excellent. So we've got 1, 2, 3, 4, 5, 6 families. And a very sad and lonely third. Oh! What are you still doing up there? You don't have anything, you got question marks. I tell you what, will you go and chat to him because he looks a bit miserable? Bring your 2 question marks over. OK, while they're coming along, we've got... Read it out. 50%.
1/2.
Shout it.
0.5.
Are you all equivalent?
Yes.
You all mean the same thing?
Yes.
Is it just a different way of writing it down?
Yes.
Brilliant. So we've got...
25%.
0.25.
1/4. Equivalent. 0.125.
12.5%.
1/8. Equivalent.
Oh, dear. Oh, dear, oh, dear. Now then, we've got a fraction, we need a decimal, and we need a percentage. But I haven't written one on. I had a problem. I'll talk to you about that in a minute. Do you know what problem I had?
Because they're 33.3333, but
Really?
put an R.
Really?
Reoccurring.
What does it mean by recurring? I'm not sure at all about this. Go on.
It means if it's like 33.333.
Yeah.
And it carries on being 33333
For how long?
forever.
Really? Got you. Now it's becoming a bit clearer. What I'd like you to do is get sat back down. I'm holding that thought. I'm holding a lot of thoughts. I was thinking about this. I was thinking just put 0.3 on. 0.3 plus 0.3 plus 0.3. We need 3 numbers, don't we? Decimals that add up to 1. What do they add up to?
0.9.
That's close enough, isn't it, Alex? No. No? You're not happy?
No.
Good. Why aren't you happy?
Because you still need 0.1.
OK. We're missing 0.1. So then I thought, well, how could we improve it? And you've given me some ideas, haven't you?
You could just plus 0.003 and then 0.3.
OK,
To the
0.33. Stick another 3 on. Just 1. That would make it 0.09. Closer? Close enough, yeah?
No.
No, all right, then I'll put another 3 on then. That'll do, won't it?
No.
God. OK, right, that's got to be enough. Come on.
No.
You're a bit hard, you lot. OK, well, I'll tell you what, I'll fill up my paper. There you go. Now then. Phew, can we move on now? OK, who said 0.3? You said reoccurring, didn't you? Who was that? Was that you, Ian?
Yeah.
0.3 recurring. OK, it means we can just go on for how long?
Ever.
Forever and ever and ever. OK? And it will give us a value for a decimal value for the fraction 1/3. 0.3. Now, if I can write that, so 0.33333 gives us 0.3. Now, instead of writing the word recurring, you're clever, you lot. Do you know what I'm going to ask?
Yes.
Okay. Who's my favourite football team? Caught you out, didn't it? Arsenal, Leeds United. Right, what am I going to ask?
You're going to ask what sign do we put.
Go on, then.
You can put either an R or a dot on top of the 3.
Do the dot. Go on, because I'm not sure what you're on about. I like it. I'm just not sure. I like the dot. Ah, and the dot means recurring, does it? Yeah. And it means it goes on forever. Yeah. Brilliant. OK. So, actually, where's that third family? Where are you? You two and the third. Could you just come back over here a minute, please? OK, do you want to be the decimal or the fraction? Who wants to be the decimal? Do you want to be the decimal? We've sussed it out. What are we going to write on here?
0.3.
With that dot on, yeah? You do that then. You write that on and hold it up to your chest, yeah? So you can show everybody with the dot right above it. Brilliant. So you stand next to your fraction. We've still got the problem of the percentage, haven't we? I know. I'll give you a start, yeah? I'll help you out. I'll put a percentage sign. Right. So any ideas? Go on, Benji.
33.3.
33.3. OK. What you've done is you've multiplied this number by
100.
Brilliant! So we've got a shiny, happy family of a thirds. Jump up and down, you're happy. Yay! Skip! Yay! We're the thirds. Come on, hold hands. Don't be shy. We're the thirds. We're really happy. Oh, sorry. We're having a private party. Right, you sit yourselves down. Give them a round of applause. We're all happy. Everybody's got a family. Fantastic. Now then, what about another fraction? 2/3. 2/3. We've not done that one. What is that as a decimal? 2/3. Ian?
0.6 recurring.
0.6 forever?
Yeah.
So you'd write 0.6, yeah?
No.
Oh, it carries on forever in a pattern. Right. So 2/3 is 0.6 recurring. 1/3 is 0.3 recurring. So, hang on a minute. 2/3 plus 1/3 is...
3/3.
Which is a whole one. A whole one. All right, what's 0.6 recurring plus 0.3 recurring?
0.9 recurring.
So we are saying that 1 is equal to 0.9 recurring. Do you know what? I'm glad you said that. Who's feeling hungry?
Me.
A chocolate bar for everybody. Okay. Right, there are 6 chunks. I want you to break. Ready? Break a third off. Break a third off. Go. Break a third. What have you done? What have you got? 1/3. How many chunks?
2.
How many chunks?
4.
1/3 plus 2/3 equals 3/3. A whole bar. There can be no doubt that 2/3 plus 1/3 equals a whole one. So what about 0.6 recurring and 0.3 recurring? Well, actually, yeah, it equals 0.9 recurring, which isn't quite 1, is it? Shall I prove to you that it is actually 1? OK, so 0.9 recurring, is that 0. Loads of 9s?
Yeah.
So what's 10 times that number? Put your hand up. Acton.
9.9 reoccurring.
So we're going to take 0.999999 forever away from 9.99999 forever. Put your hand up if you can tell me what that result gives us. 9. Exactly 9. Yeah, it gives us 9. OK. 9 take away 0. All this 0.999 forever, take away 0.9999 forever is nothing. So 9 times a number equals 9. So the number equals 1. So 0.9 recurring actually equals 1, and that's the proof. Now for the interesting bit. We're going to go back. 6 of our families had decimals like 0.1 and 0.2 and 0.01. Decimals that seem to stop, just like buses. They've got a special name. They begin with T. Now, I hope I've caught you out on this one. Surely you won't know this. Tajana?
Terminators.
Terminators.
Nators.
Terminators, like the film. Brilliant. Terminating. terminating decimals. My bus terminates at King's Cross. And then we've got another sort of decimal, which is recurring, which has digits that go on forever, 0.3333. Now, there are lots more decimals that do that sort of thing. What fraction of a football team is a goalkeeper? And who likes playing in goal? Freddie, up you come. Here's your gloves. Get them on. Get into your nets. Come on, quick, 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 quick. Here's a ball. Go on. Ready? Save it. Ready? Oh, good shot. Oh, watch the lights. Now then, he's the goalkeeper. How many people in a football team? Is it 11? 10 more. Good. Okay, Ruby. Chloe, you're in the team. Up you come. Angus, Benji, Michael, Abbe, Megan, Elena. Do you not like football? Ian and William. Up you come. Have we got 11? Come on, let's do some warm-ups. Jogging on the spot. Quick. Okay, stop. Press-ups. Come on. Oof, oof, oof. Go, you fit than me. Right, stand up. And let's all on the touchline. All on the touchline. That's it. Okay, face that goalkeeper. Look at that goalkeeper. Do you think he's good?
No.
Do you think he's very good?
No.
He saved my shot. Right, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What fraction of a football team is the goalkeeper?
1/11.
1 over 11. Excellent. So, to really understand that fraction, 1/11th, what we need to do is we want the rest of you up. Now then, what I'd like you to do is form a pattern all the way around here. But I want you to form a repeating pattern based on your gender. Get into a pattern. Go for it. Talk to each other. The first person in the pattern, we want it right round from the corner flag. Shuffle up, keep shuffling. Girl, boy, girl, boy, girl, boy. So far, so good. Girl, boy. Brilliant. Girl, boy. Hey, we're getting it. Sit yourselves down. I want you to think about that girl, boy pattern. Girl, boy, girl, boy, girl, boy. We want to write 1/11th, okay, as a decimal fraction, as a decimal. Bit of a tricky one. Let's do this one together. Okay, so, how many 11s in 1? We can put a few place values in here, okay, some zeros, okay? Because it's still 1, isn't it? 1 whole 1 and nothing in the decimals, okay? So 11s into 1.
0.
Remainder? 10. Remainder 1, Megan, okay? We can't divide 11 in. Remainder 1. 11's into 10. Can we do that? No. We can't do that. Remainder?
10.
Remainder 10. Right, 11's into 100. 11's into 100. 9 remainder? 11's into 10. I've said that before, haven't I? 11's into 10, 0 remainder? 10. 11's into 100. Said that before. What's the next digit going to be? 0.09. Keep going. 0.9. 0.9. Girl, boy, girl, boy. Just like, stop. Just like our girl, boy pattern. It goes on forever. 0.09. It was 2 digits that carried on forever, wasn't it? Not just 1, 2. Does anyone know how we could write that down with dots? William, we come. Put your dots on. Good try. And, yeah, it's not bad. Not bad. We usually just put them straight over, like so it's nice and clear. Lovely. 0.09. A 2-digit recurring pattern. Because there are other recurring decimals that recur differently. I'd like you to have a go at the division method. I think you need a bit of practice on the division, OK? I want you to try 1/7. Who's good at division? Go for it. OK, to start you off, how many 7s divide into 1? And I tell you what, I would put a lot of noughts. Goodness me, you've made a good start. Put your decimal point there. That's it, and there. Keep going. Oh, good. You might just need to put a few more noughts. OK, right, we'll hold it there. We're getting there. Daniel, come with me. Come with me. Bring your board. Bring your board. Now then, he's got 0. 1, 4, 2, 8, 5, 7, 1, 4, 2. And you stop there. Let's chant it out. 0.142 857. 142 857. OK, so we've got a 6-digit Recurring decimal. Fantastic. Wow. OK, now to demonstrate this a bit more clearly, I want you all up in any order. Grab a pen, grab a whiteboard. Excellent, excellent. All the way down the line, looking good, looking good. Get a nice, neat line. OK, so you've got an even more important thing. Can you stand that side of Tajana? OK, we've got a decimal. OK, 0 point. OK, 1, write a 1 on. 1, we're going to write this decimal down. 4, 2, 8, 5, 7. So write your digit down and hold it up so I can see it. And on, and on. Anyway, this is a very long one. How long is this going to be then? Forever. Brilliant. It's a recurring decimal. Does it terminate? Does it stop? No. Right then. On the side of the board facing you, I'd like you to write down another number. You ready? Yeah. Your shoe size. Write it down. Write your shoe size down. Are you a size 1, a 2, a 3? Lovely. So we've got 0.41. Let's shout them out. 0.
4, 1,
Shout.
3, 5, 5, 6.
Shout.
4,
Shout.
5, 3, 4.
3, 4, 5, 5, 5, 7, 5.
So what's the next one going to be?
9.
What's the next number going to be? 9, because I told you my shoe size, didn't I? What's the one after me going to be? You don't know. Why don't you know?
Because it
Why don't you know?
It could be anyone.
Could be anyone. Is there any pattern to these numbers? No. I thought there was, because we had a few 5s in a row. Then you went and spoilt it all. You had a 7. Is it ever going to have a pattern? No. Why?
Everybody can grow and everybody's shoe sizes change.
OK, just because he's a 6, does it affect what you're going to be? Yeah. No, you're in a completely random order. We have decimals that do behave like this, that carry on forever and ever, but the digits have no particular order, no pattern, they don't recur. In fact, some of these numbers are so special, they're all around us. In fact, they're absolutely beautiful. Wow. Yo, I'm MC Round. Welcome to my hood. This is my shop. Don't it look good? I don't do corners, and I don't dig straight. What I do is circles. I think they're really great. Yay, this is my shop, look at it. I don't do squares, and I don't do those silly polygons, all those straight edges. I hate them, I hate them. What I want you to do is to come up to my shop in a moment and pick something that's round. Well, that won't be difficult, because everything's round, everything's circular. I'll just check me... Oh, hang on a minute, I think I've left it on too long. But, oh, come on up, quick, it's hot. It's ready for you. Now then, form a line, form a line. Grab something. OK, there's a cake. Oh, grab it. Take your round thing and go. Lovely pork pie. We've got to do 2 important things. Do you like my bling?
Yeah, I want
it's good. Nearly a circle, isn't it? 5, break my circle right down the middle. I get 2 semicircles. What do we call that length there?
Diameter.
Is that what you're going to say? Diameter, OK. Clever clogsies. What about the distance all the way round? Now, we could say perimeter, but there's a special name. Jasper? Circumference. So, 2 measurements. Let's get measuring. And I want you to write those 2 numbers down. All the way round. OK, you put it round. Yep, that's it. Write it down. 37 or 37 point, whatever you think. So we're measuring right across. Have we measured our diameter? That's it. OK, that's your diameter. Lovely. OK, you put it round. Yep, that's it. OK, we OK? Diameter goes right across a circle. The circumference goes right around the edge. You've got 2 numbers. Brilliant. What I want you to do now is pick up your pen and your calculator. I want you to do the circumference number on your calculator, put it into the calculator, divided by the diameter number. And I want you to remember or write down the number that you get on your calculator. So circumference all the way round divided by diameter all the way across. Okay? Right, you've got a number. You've got a number. Right, come on up with your item. You're the first in the line. Bagel, what's your number? 3.16. Not bad. Take your bagel. Right. Ooh, that looks a nice cake. What was it?
3.076.
Lovely. Would you put that back in the oven, please? Okay. Excellent. Toilet roll.
3.16 reoccurring.
3.16 recurring. Put that in the bin then. Okay. What's this?
3.5 recurring.
I meant what flavour? Oh, sorry.
3.5 recurring.
3.5 recurring in the bin. So go and sit down. 3.5. Brilliant. We've got lots of values here. A lot of them start with 3 point. This young man here was whittering on, wasn't he, about having some pie. And I told him it was a quiche, but he still's going on about his pie. So shall we let him have a say about his pie? What were you talking about with your pie?
Because you don't need to measure the circumference, you just need to do the diameter because you just times the diameter by pi, which is 3.14.
You think pi is 3.14. So you're giving this division a special name. You're saying that if you get any circle, yeah?
Yeah.
And you measure its diameter all the way across, and you multiply it by
3.14, but the actual calculation of pi is a 40-digit number.
It's a magical number. And it does actually go on forever. I need 4 volunteers. Okay. Jasper, Daniel, Megan and Astrid. Okay, Megan over here. Put your finger on the top, your finger underneath. Lovely. Astrid, you can be the roller. Guys, stand behind them. Pull it out slowly. 3.141459358979323864263. Wow, it goes on and on forever. Is it recurring? Is there a pattern? Can you spot a pattern? There's 2 3s. Is that a pattern? No. There's no pattern at all. It goes on and on forever and ever and ever. It's called pi. People have thought about this number for ages and ages. In fact, people with computers in this day and age have actually calculated this value to 80 million billion digits. You can go onto the internet and actually look at the value as it currently stands. Okay, so pi has no pattern at all, and no one's ever been able to discover a pattern. Okay, if you'd like to put your pies down, the pi number, okay, and sit yourselves back down. Okay, so pi is a decimal that goes on forever. It looks beautiful, and it's all around us. We can actually use pi. Now, if we make it 3.14, it's a good approximation, isn't it? 3.14? Pretty good. Okay, so when might we use pi? Well, I need a couple of volunteers, actually. Elena and Rian, up you come. It's a pretty big tyre. Uncle Tom, my great Uncle Tom, used to be a farmer, but he's retired now, and he's left me this wheel. It's pretty big. It's pretty big, but it's circular. Here's a question. Ooh. I'd like to place my eggs as close as possible to that tyre, so that when it does one complete turn, it doesn't crush them. How close can I put my eggs to that tyre so that it can get as close as possible without getting crushed? Do you think I could put it here and get away with it? Yeah. Hold it, hold it, hold it. We're just guessing, aren't we? What's the point of guessing when we can work things out? Right then, another couple of volunteers. Benji, Megan, up you come. Benji and Megan, we've got some metre sticks here. First of all, I want you, 1 metre stick between you, to measure from this side the diameter. Let's measure it across. Okay, we're going right across. It starts here, so it's actually over 100 centimetres, isn't it? What have we got? Have you got it yet?
114.
Pretty good. 114. Write that down. 114 what? Metres?
Centimetres.
Centimetres. Okay, brilliant. Or 1.14 metres. I like decimals. Let's stick with 1.14. What do we have to multiply it by to get an idea of the circumference? Alex? 3.14. Let's do that on the calculators, yeah? Anyone got an answer? What have you got?
3.5796.
3.579. What about that bit? Say 58? Do we all agree? 3 metres 58?
Yeah.
3 metres 58, okay. Let's have a look. How far can we get them? So if we put a bit of tape there, do you reckon, Ruby? So as soon as it hits that, it's going to get crushed. So, guys, with your measuring sticks, I want you to measure from this point. We'll lay the first stick down, like so. Okay, that's 1 metre. 2 metres. And we need another stick. Do you want to use that one? Okay, so to there. Do we put it there then? Like that, are you happy with that? Do you want to adjust it a bit? Yeah. Okay, move your sticks out of the way, let's roll it. Okay, everybody sit down apart from the 3 rollers. So, do you want the eggs to break? Do you really want the eggs to break? If you want the eggs to break, shout, break! Break! I think most of us want to shout, break. Are you ready? After 3. 1, 2, 3, let's roll. We're waiting for that tape to come back round. It won't break. So we've managed to use the maths to do a calculation and we've achieved a result. But the thing is, put your hand if you really wanted to break them. Around here. Shall we? Shall we? Shall we? Ready? 1, 2, 3, break them! Yay! Brilliant. Fantastic. Oh! Now then. Oh! Hey! This is no joke. Oh, look at that. Scrambled eggs. Right. Okay, but a cracking time. We've looked at numbers, decimals that go on forever and ever and ever. And they were really fun. And we've looked at pi in particular. That's a special number. It's all around us. So there you go. We've looked at all sorts of decimals. We've looked at terminating decimals, recurring decimals, these funny decimals that don't have a pattern. It's fantastic. One thing's for sure, decimals are great. You know what I say? I love decimals. Decimals forever!